So the independent variable is the factor that I'm going to manipulate in order to test my hypothesis. Remember, the hypothesis was that Ultra Grow, this magnesium enriched fertilizer, would cause pepper plants to grow at a faster rate than plants not treated with the Ultra Grow. So, to put it simply, the independent variable is the one thing, the one factor that is different about how I'm treating the two groups of plants. Okay, so this plant is going to receive 5 milliliters of Ultra Grow fertilizer per week, and the other plant will not receive any Ultra Grow. And I'm simply, this is a very, very simplistic example, but I'm simply going to compare the growth of the two plants and maybe eventually compare how many peppers they produce. So the one thing that I do differently is called the independent variable, and the dependent variable is whatever I'm going to measure. I'm looking for a difference, right, between these two groups of plants. I'm looking to see, did the Ultra Grow cause some measurable change or some measurable difference in plant A? So the dependent variable in this case would simply be the growth of the plants. And so you can see I've just made up some data here. Let's say that the plants started out week one about the same height, 5 or 5.5 inches. And then I recorded the growth of each plant weekly. And it doesn't take a rocket scientist to figure out that plant A did, in fact, grow at a much faster rate than plant B. And they were growing in the same type of soil. They received the same amount of water, same amount of sunlight. So presumably, the only difference was that one thing, that one factor, the independent variable, which was that plant A received Ultra Grow and plant B did not. So students often get confused with these terms: independent variable, dependent variable. One way to sort of keep it straight in your head is that independent variable starts with the letter I. And so let me grab the right tool here. So if you just think, if I'm doing the experiment, the independent variable is the thing that I control, the thing that I am manipulating. I'm deciding which plant gets the Ultra Grow and which plant does not. So if I'm in control of it, it's the independent variable. Whereas the dependent variable depends on the independent variable. That's why it's called that. In other words, this plant grew more, presumably, because of the Ultra Grow. The increased growth depended upon the Ultra Grow. Now, the other thing I should point out here, let me get rid of this pointer tool, is these terms up here at the top. You see experimental group and control group. You've heard these terms before. So the experimental group, or the experimental plant in this case, is simply the group that receives the independent variable. In this case, that was plant A. The other plant, the one that we call the control, it does not receive the independent variable. So the control is there for just comparison. You might think, well, golly, why not just get a bunch of plants, give them all Ultra Grow, and see if they grow well? And of course, the problem with that is obvious. If you did the experiment that way, and every plant or both plants received the Ultra Grow, and let's say they both grew well and they were healthy and they produced lots of peppers, that might be because of the Ultra Grow, or it might not. It might be that there was something in the soil that made them grow well, or that they were just genetically healthy plants and they were going to produce that many peppers regardless. So the only way to be sure is to just have one variable, that one independent variable. And if that's the only difference in how you treat the two plants, you can be reasonably confident that that the Ultra Grow did in fact produce the increased growth. And so the control group is important so that you have something to compare the experimental group to. So if our hypothesis was that ultra-grow increases the growth of the plant, the data certainly supports that hypothesis. And our conclusion would be hypothesis supported, ultra-grow seems to in fact be a useful product. So another example that I just want to throw out here that's maybe a little more real world and certainly has greater implications is what's called a double-blind clinical trial for a new drug. And this is just kind of a little humorous take on this term. It's a confusing term, double-blind. This is the kind of research or experiment that's done anytime a new drug is being tested before the FDA approves it to go on the market. And the way it really works is this. So let's say I'm a scientist working for a pharmaceutical company, and I've developed what I hope will be a very effective new cancer drug. And obviously, this kind of thing, you would test it on animals first, and if it shows promise and it seems to be effective and it seems to be, creating more good than harm, then you at some point have to test it on humans. And so what you would do at that point is you would get a pool of patients, that is a group of people who all have the same type of cancer. Let's just make up something. Let's say it's brain cancer. They all have the same kind of tumor, and they are all willing. They have to sign waivers. They're willing to participate in this trial. So in order to have constants, we need to divide the two, or divide the group of cancer patients into two separate groups. And that needs to be done in a random fashion. And it's important that both the control group and the experimental group be very, very similar, that their age distribution would be similar. The breakdown of male-female should be the same. They should be on similar diets, similar exercise regimens. It's hard to control all the variables, but you would like for both groups to be as similar as possible. Because remember, you want there to be one independent variable. And in this case, it would be this new, what we hope is going to be this new treatment or this new drug that we've developed for fighting cancer. Anyway, the reason this is called a double-blind study is because one group is going to receive the drug and the other group is not. They're going to receive a placebo, which is a pill that doesn't have any medicine in it. It's a sugar pill. The patient, if I'm a patient in this study, I don't know which group I'm in. I show up to the clinic every day. I receive a pill. I don't know if it's a sugar pill or if it's the real thing. So I'm blind in that sense. I don't know what pill I'm taking. It's double blind because guess who else doesn't know? The doctor or the nurse giving me the pill also doesn't know which pill I'm receiving. Now, somebody obviously knows. Somebody's keeping up with it. But the idea is we would have a control group that receives a placebo each day, and then we would have an experimental group which receives the independent variable, which in this case is the cancer drug. And we're going to measure the effects. That is to say, both groups, we would measure the size of their tumors. Are they shrinking? Are they growing? And at the end of the study, hopefully the experimental group will show a dramatic reduction in tumor size and maybe even be cured. And in the placebo group, the control group, probably the tumors are going to be the same size, or maybe they've continued to grow. Now, you might think, well, this is horribly unfair. What about these poor folks in the control group? And it does seem unfair, but this is the only really reliable way to know for sure that it is the drug that's causing the improvement in the tumor. And the studies have to be done this way in order to make sure that the drug is safe and useful. Now, eventually, the control group would be given the medicine as well. If it's proven to be an effective drug, then at the end of the study, the control group would be given access to the medicine.